You would think, me being a millennial, that I would know the Gen 1 type chart like the back of my hand. But I'm old now, I need to rely on technology, so I made an app to help me live as I play, and then spit on some other project ideas. But let's start at the beginning. I recently found my old Game Boy and wanted to replay Pokémon, but I'm not the very best. I kept having to refer to online resources. It's not fair. The Pokémon World Champion Ash has a Pokédex, and well, I did have my own when I was younger, but don't tell Professor Oak, I lost it. So I overlaid this image to fool myself into thinking I still have it.
Ben Edwards, give us a good final fight here.
The initial spark which rekindled my fondness for the old Pokemon games was watching Retrobound play them, a solo runner which takes one Pokemon throughout the entire game. I liked how the attacks a Pokemon could learn were displayed on the side, along with the other information about the Pokemon. But when I was playing, my immersion would be broken by searching on Bulbapedia for what moves there were and what type of effectivenesses they had. I could replicate this through of the game by using an emulator and having a web page open in the background, but I would still have to manually go and search the references for every encounter. What if there was a way to automate the viewing of this data? Indeed. All this information is available on various Pokemon wikis, but I couldn't think of a way to actually display them without me leaving the game. Immersion ruined. So I would have to bring all that information to me, so that I get to control the display of it. There is a certain word use when doing this kind of activity, and I'm not sure if it's going to get me into trouble. But to use a Gen 1 move, we are going to use Scratch on the web pages. And no, not the block-based programming tool. Firstly, I needed all the moves a Pokemon could learn. So what I did was go through every Pokemon in the list, click on the Pokemon to open up more data about itself, get the image of the Pokemon, the Pokedex entry, the learn set, and while I'm here, the TM list, that will be handy. Then I will leave the page, but some last minute nibbles, the base IVs of each Mon. I'll have them too, and I do this for all the Pokemon. When I was going through all this information, an issue that I had was something triggered my unhandled error exception. It was Pikachu? And Metapod apparently. Some moves are only available in some games, so when I was trying to write NA, I didn't know how to interpret it. Pikachu can learn Payday, eh? Who knew? Running again, and who's giving me a problem now? Oh no. Oh, of course it had to be you. Hey, did you know? Taurus dung aside, it took me so long to learn HTML and AngleSharp, a C# HTML parser, that it probably would have been quicker for me to go through and copy everything manually anyway. After I finished, I thought to see if anyone had posted the database. If not, I would upload mine. Unsurprisingly, people have already done it and done a much better job than me, so meh. But oh well, I've learned this now, and you can't take that away from me. Hello? Nintendo? No, please don't take it away. One thing I had forgotten about is that the Pokemon in-game do not equal that of the Pokedex, so we will have to make a comparison table for that. From here, I have all the data I need. I just need to decide how I want it to be presented. I was going to record all new voiceover for this video, but I must have been sleep deprived from recording the original footage as I get a bit unhinged in a few of the clips, so I'm going to leave them in. Next, I'm just going to test the display with hard-coded values. So get whatever the in-game ID of 30 is, display its entry, and then actually try and display a picture. But I don't know if it'll do that yet, so let's have a look. And it kind of works. So I need to sort out this nonsense here. Let's have a look. Ta-da! Oh, it zooms the entire thing. I quite like this thing though. It doesn't go on the page, okay. Just need to change this so it's a bit neater. Let's change the ID 30 because this is a problem now, because I don't know what the IDs in games are. Of course it doesn't. Missing number. Of course. 25. Yay. There we go, look at that. That works. I still needed to get the information from the game to know which Mon is to be presented. I knew this project would be possible because of this old Tony. Sorry, wrong school of passion. I meant Lord Tony, who shows how to read and manipulate emulator memory. The second person to inspire me for this project. Why emulators are a good start is without any other special tool, we get to look at the whole memory which would otherwise be impossible to see on physical hardware. I named my character BBB Bowley, so if we scroll through all this memory, seeing here as bytes, which the computer understands, and here are the ASCII characters, which humans understand, we are going to keep scrolling and look out for BBB Bowley. Okay, I've scrolled through the entire memory and found nothing. I'm missing something. But luckily, since the Game Boy is a simple machine, we can reliably look up online references to tell us where specific game values are stored. I found this site, Data Crystal, which will be doing a lot of heavy lifting in this project, which tells me where I need to go to find the player name in memory. See this number? What do you mean that's not a number? Just because there's letters in it? Remember when math got hard when you started putting letters into it? Recall that knowledge now and look again. See this value? This is the address of the memory for the Game Boy. So remember this value. Looking through the memory viewer for this address, we get some numbers. These mean nothing to me. But I do see a pattern of 4 of the same number, and I have 4 B's in my name. So this may be the player name. So what's going on? Well, earlier I said ASCII, which is a way of assigning numbers to letters. But the Game Boy doesn't need to conform to this standard, so they made their own. I found this chart, and using it we can see the first letter 8 means that we need to look at this row, and this value of 1 means we look down this column and we find a B. So the memory actually reads out BB Bowley, which promptly led to me saying, that's not my name. It does actually say my full name in memory, but the address is 1 off. Turns out there's a 1 byte offset for mostly all memory regions for Pokemon Yellow compared to Red and Blue for some reason. Maybe that's the reason it's called Special Edition. I'll be sure to remember this, he said overconfidently. But this address is the mimicked address of the Game Boy, which the emulator is showing us. We cannot do anything with just this view, as it is just showing us the values. We cannot gain access to it for us to use in our own program. To do this, we need to use a more powerful tool to look at the actual location in your computer's RAM, where the value is stored. I tried to display a size comparison for the Game Boy RAM versus my current PC's RAM, but the size is so vast that you cannot see the difference. So as a value, the Game Boy has 65,000 memory locations, where 16 gigabytes of RAM has 17 billion locations. 262,000 times more memory. The program I am most confident with memory reading is Cheat Engine. This isn't going to be a tutorial, but I will explain what is happening. We first have to tell Cheat Engine what program we want to look at, and then I'll let Old Ben explain this. Sorry for the audio quality. We know that this exists in memory, so I'm going to search for that here. So Cheat Engine has only found one place where this pattern exists. We can click on this value to check the surrounding memories. I'm happy that this memory region is what we find in the game here. So I now have the address of our player name. We can test this because if we look in the game, this is our player name here. But if I go into Cheat Engine and change this to 128, and then we go back into Pokemon, our name has changed here. So, and Pikachu knows this because he's just f***ed off as well. Cheat Engine proves that we can find a value in memory, read it, and change it. What we can do then is make a simple program which, when I click, reads it, and then this just converts the values that we saw previously, minus 63 to get an ASCII value, and then update the player name. And there we go, we have our player name. So now all we have to do is look at here. For example, here's all the battle memory addresses, and we got our enemy Pokemon internal ID and our player's Pokemon ID. So we can just change now the address to read from the name to the Pokemon we want to see fight. So enemy Pokemon's internal ID, so CFT8, CFT7. So this is the region that we're looking at, and this correlates to what we see in the game. So these are the two values up here we're looking at now. This one then must be our player's Pokemon internal ID, and this one is the enemy's Pokemon ID. So yeah, so if we look at these values here, these should match up. We want to be looking at this one because we know this is the actual memory address that we're looking for. So, oh, Pikachu's back. That is because I changed my name back, and he's like, ah, Sokka. Hey mate, how do I interact? There we go. He's happy. He's back. He knows who we are. Come on, fight me in. Fight me. Oh, did it change? 24. Right. Okay. Perfect. And 24 there. So, bugger, where's that gone now? Let's first look at 24. What we are fighting. Again, we're looking at the hex value here. So it's going to be a Pidgey. Okay. We're expecting to see a Pidgey. And then what's 54 then? Can we guess what 54 is going to be? 54, it's Pikachu! These I'm happy with. Not that we're going to need our internal ID. Actually, no, wait, we are going to need our own internal ID. This will be good. So then we can see then if we are weak to an enemy's attack, we can withdraw. And speaking of which, down here, we got the enemy's move. So we could potentially add here what the enemy's moves list entails. So we can say, oh, if an enemy moves is going to be super effective against ours, retreat or stuff like that. So that might be something to expand upon. Move this back over here, please. So first of all, let's see, are we fighting a Pidgey? We are fighting a Pidgey. Happy dude. Right, let us now see if we can't search for this memory address. A5 Rattata? Was that potentially Rattata? Yeah, it's Rattata. Here now we are going to try and find out. Well, we are going to read this memory address, CFD7, and then obviously use A5. That is going to be fed into indexed pokedex. Then obviously in here it's going to be Rattata, and then update everything there. So let's try and do that now. Let's try this. If we click read, I mean, it read the last one. Oh god.
This is actually a good result. The only reason I was deflated was because it was displaying Rattata and it wasn't in a fight.
Also, we got an error. Okay, let's try this again. There it is. Let's click read. Rattata. Okay. So at least the UI works now. But obviously Rattata has been pulled in because Rattata was the last Pokemon we fought. And that memory, there it is, this memory doesn't get cleared after the fight. Let's see then if this will update to Rattata again, I believe. It is. Yes. Never mind. Getting strong. Okay, this has changed, I think. Okay, third time is the charm. So now it's infinite loop. There we go. Pidgey, this one should have happened last time. E5. Rattata. There we go. So we just need to figure out when the battle is over to clear it. So I'm going to have a look down here. This should be everything to do with like a battle. Just see if anything changes here. We can see a few things like dotted around here. But at least we knew now we were going to fight with Pidgey before we actually went into the fight. Nah, it happens a bit too quickly. So, reading through the memories of the battle section, coming down here, nothing of these are important. We get TO57, type of battle, the battle type, so it's a normal battle, for example. Let's have a look what this does first, because I haven't actually seen this yet. D057, it's this one here. It's not 057, it's 056 because bloody Pokemon Yellow being a -1. Let's go fight a kite. So again, we're hoping. Oh, 1! It becomes 1 during a fight. Okay, but anyway, 1, whatever that means. Oh, it goes to 0! Oh, we're gonna use this! Alright, how do we do this? Should we just run this, see if it's working? Working. Yeah, here we go. Yomon here. I did have to click that, okay. On in battle, wait to encounter. Okay, this looks good. Wait, where's it gone? Okay. I think we're ready in a fight.
Oh, it looks like it's working so far. Oh, not a battle. Oh, it works. Everyone, it works. We're the best. I couldn't have done it without you. There's a Pidgey. What do you think, Beak? Just nothing. Music stopped. Just oh, come on, Rattata. Here we go. Maybe I'll delay this. I think I should delay that. Wait a second. Okay, so far so good. Maybe it's 4 seconds. Okay, so I think I need to change this. So, are we become Cup in battle? I mean, sorry. Right, so I have added now some comments. If you want to have a little read of that. Okay, moving on. That's boring. Boring. We're gonna hop up. Yaman here. Yaman here. Sorry, I'm just something extra in a minute. Wait for it. Wait for it. Taratata. Oh, I did press read. We sorted it. Come on. We'll get 1, 2, 3, 4, 5. Yeah, okay, that's like it. Ready again, ready for this to go to 0. Oh, that was actually perfect. Okay. Really happy with that. I was very happy with what I had so far. A live tool which could react to any state of the game. This is all I have time for in this video, so be sure to like and subscribe. I hear YouTube likes that sort of pandering. Then watch the next episodes next week sometime, where I work on the type advantages and display them. I have had some help editing this video, as well as some quality assurance. Thank you so much for watching. Be sure to watch the next 2 upcoming episodes where I push the tool further.